Hello students of Group 602, I'm Professor Franco. In this video we will present the presentation of environmental aspects of biopolymers and biodegradable polymers, which also means aspectos ambientales de los biopolímeros y polímeros biodegradables. I hope you like it as well as clarifying your thoughts, and this subject will start.
Biopolymers are large and complex molecules that are derived from natural sources, such as proteins, carbohydrates, and nucleic acids. These polymers are biodegradable, meaning that they can be broken down by natural processes such as microbial degradation, enzymatic degradation, and hydrolysis. Biopolymers have gained increasing attention due to their biodegradability, abundance in the nature, and potential for sustainable development. They have been used in various applications, such as food packaging, agriculture, textiles, and medical devices due to their eco-friendly properties. These materials can be tailored to have specific properties, such as degradation rate, mechanical stretch, and biocompatibility, making them ideal for use in a variety of applications, such as drug delivery, tissue engineering, and environmental remediation. Synthetic biodegradable polymers can be produced from renewable resources, which makes them a promising alternative to conventional polymers that persist in the environment for decades or even centuries. Biodegradable materials play a crucial role in reducing environmental pollutions caused by non-degradable materials. The accumulation of non-degradable materials, such as plastic, in the environment has become a major global concern due to their persistence and adverse effects on ecosystems, wildlife, and human health. Biodegradable materials can be broken down into simpler and non-toxic compounds by biological processes such as microbial degradation and enzymatic hydrolysis, and thus they do not accumulate in the environment. Moreover, biodegradable materials can be produced from renewable research, such as plant-based polymers, which further reduce their environmental impact. Biodegradable materials have the potential to reduce the amount of waste generated, decrease the use of non-renewable research, and mitigate environmental pollution. Therefore, there is a growing interest in the use of biodegradable materials to promote sustainability and environmental protection.
Comparison of the carbon footprint of biopolymers and synthetic biodegradable polymers with the conventional materials. The carbon footprint is the total amount of greenhouse gas emissions produced by an individual, organization, or activity. Only during the production of the polymers, the carbon dioxide emissions values are between 2.5 and 3.4 kg CO2 per kilogram of polymer. Energy necessary for its elaboration is between 73.7 and 85.9 megajoules per kilogram of polymer. The handling of the synthetic polymers during the manufacturing, as well as disposal methods after their useful life, have a negative impact on the environment. Data shows that in 2015, 20.6% of the synthetic plastics were incinerated and 31% were sent to landfills. That same year, not only was toxic waste generated by the incineration and disposal of polymers, but it also generated a loss of 1.9 billion euros. In 2019, plastics produced 1.8 billion tons of greenhouse gas emissions, representing 3.4% of global emissions, and 90% of these emissions come from their production and processing from fossil fuels. By 2060, life cycle emissions from plastic will more than double to reach 4.3 billion tons of greenhouse gas emissions. Carbon footprint of biopolymers. Biopolymer production is a promising approach to achieving a negative carbon footprint by reducing greenhouse gas emissions. Biopolymers are readily biodegradable and are broken down by microorganisms into a natural compound such as water, carbon dioxide, and biomass. All biopolymers are derived from resources such as corn starch and sugarcane. By emitting less greenhouse gases, biopolymers can be adapted from various applications such as packaging, agriculture, medicine, and food. Biopolymers can be used to produce biodegradable packaging materials and compostable, such as bags and containers. In agriculture, they are used to produce biodegradable mulch films, which help retain soil moisture, control weeds, and promote plant growth. In medicine, they can be used to produce thirds, biodegradable, and drug delivery systems. Biopolymers can be used in the industry of construction to produce biodegradable building materials, such as insulation, ceilings, and floors. Impact on biodiversity of polymers, biopolymers, and biodegradable polymers. About 60.5% of Brazilian sea turtles and 44% of seabirds were affected by the ingestion of polymers. The size and concentration of synthetic polyethylene particles affect excavation activities by causing stress to the more than 100 species of earthworms that exist today. Microplastics have been found in the air in remote areas, including the Arctic, and may contribute to accelerated warming by absorbing light and reducing the albedo of the snow surface. Plastics non-degradable materials leak into the environment and generate microplastics, whose high mobility causes and affects water pollution worldwide, human health, and animal. Biodegradable microplastics have been found to affect negatively to marine and freshwater life, but have even less impact on the ecosystems compared to their petroleum-based counterparts. Biodegradable plastics were found to degrade much more slowly in turtles compared to their assumed biodegradability. Even so, plastics biodegradable will continue to have an undeniable positive impact on the uses to which probably reach the environment.
Hello, I will explain different degradation types of biopolymers and biodegradable polymers, factors affecting rate of degradations, and comparison with conventional plastics. For years, human beings have been manufacturing plastics for use in everyday life, from grocery bags, used in daily transport such as tires, or simple or clothes that we wear every day. People near the coast where they carried on their lives in a calm way and without any problem, began to run into drink bottles, dishes, clothes, and endless number of utensils arriving on the beach, affecting millions of marine spaces. Since the law of conservation of matter tells us that matter can change its forms, either by physical or chemical changes, but throughout any of these changes, matter is conserved. Our garbage, such as everyday items, could exist much longer than we do, since a plastic depending on its structure on other environmental factors. It takes from 20 and 500 years to decompose, a real barbarity. With this phenomenon that began to be seen in many parts of the planet, a way to reduce carbon footprint emissions from these plastics began to be sought, and with this sadly more viable alternatives arrived, which are biopolymers and biodegradable polymers. There are many types of polymers that little by little are becoming redundant in society, such as sugar-based polymer. They use resources such as starch or sucrose, carbon components that come from vegetables such as potatoes or corn. These are also, and lactic acid polymers, starch-based polymers. This type of polymer acts as naturally occurring polymer, which is made up of glucose, also known as vegetable sugar. This type of monosaccharide is found in plant tissues, that is, in fruits or vegetables, and even plants. Cellulose-based polymers is other type of biopolymer and type of bioplastic is used in packaging. It also occupies of glucose compound, but is mostly obtained from resources such as cotton. Cellulose biopolymers is the option of the human being and for the planet in our cellulose-based biopolymers, since it is the most abundant renewable resource on Earth. The cell is present in plants, algae, and even some bacteria. However, it's very substituting for containers or from petroleum. Its current is occurs in the packaging of cosmetics, textiles, and as well perfumes. The great advantages of this type of cellulose-based bioplastic is the low cost involved in making products based in this carbohydrate, which since it's not abrasive or toxic, make it very good example to achieve sustainability. These types of molecules such as cellulose contain distant and loosely bound molecules that can be rapidly degraded, although to make it somewhat more durable in terms of utility. The links are reinforced with glycosidic bonds, so that there is no affection to the land in degradation. It's thought that composing is reached. In this case, this type of containers that use cellulose as a basis of containers, it was found in that period of 47 days that 100% of the cellulose had been mineralized, thus achieving a static composing, which had a normal in soil temperature in summer. After just over 94 days, the natural basic utensil could already be completely degraded. Then we continue with the starch-based polymers. Starch in recent years has become very relevant throughout that the fact that a way to create naturally biodegradable polymers was found produced in bags or packaging that had a much lower carbon footprint, in addition to the fact that is a material with very good qualities to replace starch. The plastics biodegradable the polymers are made from vegetable bases such as potatoes, corn, rice, wheat, barley, and even cassava. Its current applications are in medicine, the packaging industry, agriculture, and the textile industry. Its composition makes it a compostable material, which means that its biodegradation is very beneficial. Since starch or cellulose can produce enzymes that can mineralize this starch, the biodegradable of some biopolymers in two stages. The first stage happens in period of 24 hours, where the material is dissolving in water around 30% of the weight in loss, and in the second stage of happens in a period of time of 20 days, where here most 90% of the original weight of the utensil happens has already been requested to the microbiological activity that occurs in the environment. However, many times the some conditions are not achieved to able to biodegrade a material. And with this was invented that road mesophilic composting, which a composting that means is an ambient temperature between 23 and 25 centigrades. It is also possible to achieve it very good in degradation results, a little slower but just an effective, where in approximately 9 weeks the biodegradable polymers was already useful to the soil without causing a malignant agent for it. PLA, polylactic acid, is a biopolymer, also known by its acronym PLA, which are promising plastic that is produced by material. It is of vegetable origin. This biodegradable polymer is currently the most used manufacturing in bottles, medical devices, screws, pins, rows or plants, plates, bags or plastic wrap for packaging. In addition, it is the quick innovated material has begun to be used by young people, since it's that use our three-dimension printing technology that is the last 4 years has been gaining a lot of value, and thanks its codes. The quality of this material is very good because it offers a no shine and properties very similar or polyethylene. The biggest advantage that is biomaterial has is that is compostable. First going through hydrolysis and metabolization of certain organisms so that they return products such as dioxide of carbon and water to the environment. Enzymes such as carboxylase derases, lipsases, cutinases, and proteases, among others, are involved in the plastic composting process. The composting process of these materials that occurs in the industrial process requires of temperature or 55 degrees centigrade, where are 30 or to up of 70 percent of the weight of the material products in this composite, achieving the ability to completely degrade of bioplastic within 4 to 6 weeks at a natural level and without there being a change in temperature or seeking the generation of an acid for the decomposition of the plastic. This will take 6 to 12 months. We continue with plant-based biopolymers. Plant-based biopolymers have gained such a relevance in recent years because they offer the same properties and polymers of industrial origin such as plastic. An example of them are the straws made with the cell of different fruits or plants that promote recycling or separate garbage. The most widely seen examples are straws made from non-plastic elements such as cornstarch, avocado shell, agave fiber, etc., which take around 114 years to biodegrade when a plastic straw takes more than 100 years or disappear. The next biopolymer is PHA, polyhydroxyalkanoid, also known as PHA, is a natural biopolymer that uses microbial synthesis to generate a structure that is used in three-dimension printing, packaging, and agriculture or medicine. Although lately it has been getting to create PHA through sewage streams, plastic, renewable methane, and carbon dioxide, where in a pH condition at a low temperature you already begin to see a biodegradation. But when these biodegradable reduces are exposed to temperatures between 80 and 13 degrees centigrade for almost 190 days, as a mass loss almost and 60% was achieved, but with higher temperatures in intervals of the 34 to 66 grades in condition of 74 to 89% humidity in periods of 80 days, and there were results or loss of 0.5%. Then we find BioPET. BioPET, this is main substitute for a PET, which is being made from renewable raw materials, where sugars or derivatives from vegetable sources are used, forming polymer chains that are durable, highly resistant, as well or transparent. These are a 100% recyclable, and this is what takes this polymer and sustainable polymer since for the considered a biodegradable polymer, that the goal of being to able to grade on 60 to 70 25 in 6 months has not yet been reached. The other biopolymer is the alginate polymers. The last of the proposals, but not least, is the alginate polymer, which is a natural biodegradable polymer, which contained throughout brown algae and microorganism cultures. This biopolymer is the most used in different human daily environments, as are the pharmaceutical, food, paper, artistic, construction, chemical, and textile industries. Among many others, it is very good material. However, its non-material has a good mechanical properties, and since when dehydrated, it becomes a very brittle material, and therefore is sought to improve the physical and chemical and biological properties, or this so that they can have better performance in mechanical matters, eat water absorption, and to avoid antimicrobial activities. Now, certain pros and their biodegradation period. Materials of daily use and an approximate period of time that it takes to completely degrade at present. Vegetables 5 to 31 days, paper 2 and 6 months, plastic bags 5 years, 500 years, cigarette butts 10 and 12 years, monofilament fishing line 600 years, plastic cups a half years is 50 years, cotton glove 3 months, cardboard 2 months, cans 60 years, rope 3 and 14 months, aluminum cans the 100 years, batteries 100 years, wood and 10 of the 16 years, wool clothing, and is the period is the 1 and 6 years. Aluminum foil does not biodegradable, and other materials. These mentioned are not to make someone feel bad, but rather to report how long an item takes to degrade, and thus to be able to see that is we occupy something or use plastic or plastic utensil, we must treat that item after use to that is does not contaminate more than it has already polluted by being produced. And that's all for my part.
Change in biodegradable materials production. High cost of production compared to traditional plastics, specialized equipment, and raw materials need. Production process not fully mature, room for improvement in efficiency and cost reduction. Compatibility with existing waste management systems, specific degradation conditions required, risk of contamination with conventional plastics. Biodegradable materials need specialized infrastructure for their management due to the requirements for degradation and the risk of contamination when mixed with traditional plastics. The cost of production and market price of biopolymers and biodegradable polymers are crucial in determining their competitiveness and adoption. The cost of production are influenced by several factors such as raw material cost, production process efficiency, and scale of production. The use of recycled materials can reduce cost and promote sustainability, providing economic benefits. Market price of biopolymers and biodegradable polymers. The small market compared to traditional plastics. Expected growth in the market, influenced by regulations, technology, and consumer preferences. The market for biopolymers and biodegradable polymers it is small compared to traditional plastics. but it is expected to grow in the coming years. This growth will be driven by increasing environmental awareness and regulations of plastic waste reduction, as well as technological advancement, innovation, and consumer preferences. Ensuring performance and quality of biodegradable materials. Mechanical properties limitations. Harmful substances released during degradation. Consistency and predictability in production. Biodegradable materials need to meet the same standards as traditional plastics while being sustainable and environmentally friendly. This requires careful consideration of mechanical properties, degradation process, growth of biopolymers and biodegradable polymers. The biodegradable polymers and biopolymers is an industry to expect to grow in the coming years. All of this is thanks to the regulations of plastic waste reduction and be influenced by technological advancements, innovation, and consumer preferences. These materials surge efficiency of production process and development of waste management systems, and want to create opportunities for business and industries, particularly in packaging, agriculture, and textiles.
My name is LEDESMA CUEVAS, and I'm going to talk about how toxic are biopolymers and biodegradable polymers in different environments. First up, a little context. Conventional plastics are known to be harmful to the environment, mostly due to their known biodegradability. Plastic waste can take hundreds of years to decompose and can cause harm to living organisms during that time. Also, plastic can release toxic substances to the environment as it breaks down, causing several different problems to the environment around it. The disposal of this type of plastics also represents a significant problem, as plastic waste can end up in landfills, oceans, and other natural habitats, harming wildlife and polluting the environment. The Great Pacific Garbage Patch serves as an example of this, being a huge collection of debris in the Pacific Ocean, mainly microplastics that come from various countries in Asia. And this patch has gotten so big that its size can now be compared to Australia or some states in the United States. Due to this problematic, it was necessary to find a different alternative to conventional plastics that wasn't toxic. This is where biopolymers come in. Biopolymers and biodegradable polymers were created with non-toxicity in mind. They are made from natural materials such as starch, cellulose, and proteins, while being designed to break down naturally in the environment. The use of biodegradable polymers also has environmental benefits, such as regeneration of raw materials, biodegradation, and reduction of carbon dioxide emissions that lead up to global warming. Also, they are non-toxic for humans and animals. They do not pollute the soil, groundwater, the oceans, or the atmosphere as opposed to conventional. However, a study made by the Norwegian University of Science and Technology suggests that bioplastics are similarly toxic, based on the research using bio-based and biodegradable products, mostly food contact materials. They found that 67% of the samples induced baseline toxicity, 42% oxidative stress, 20% anti-androgenicity, and one sample estrogenicity. In addition, some bioplastics are made from biodegradable polymers such as polyhydroxyalkanoates, PHA, which can release toxic compounds such as formaldehyde during their biodegradation process. Now, let's compare conventional plastics with plastics based on biopolymers and biodegradable polymers. Biopolymers and biodegradable polymers are in general a better alternative, because they are made out of natural materials and can break down organically in a short time. They are usually not toxic, and although they can be, the release of toxins to the environment is vastly reduced. They have a lower carbon footprint, and their fabrication involves fewer harmful chemicals. In comparison, conventional plastics are petroleum-based, can take hundreds of years to decompose. They are very toxic and polluting. They can release harmful gas emissions. They have a larger carbon footprint, and their fabrication often involves use of fossil fuels and other polluting processes.
As we know, petroleum-based plastics are terrible for the environment. That is why humans have been searching for new solutions, such as synthetic biodegradable polymers. And even though petroleum-based plastics are significantly worse than these plastics, current research has demonstrated that polylactic acid microplastics have a significant influence on marine biota. The polylactic acid is one of the most widely produced biopolymers. The scientific community has recently expressed interest in the ecotoxicological assessment of lactic acid microplastics. Few studies have been done on the effects of these microplastics on a small number of aquatic species, but those that have been done have shown that these contaminants can sometimes have an adverse effect on those that are exposed to them, much as petroleum-based microplastics. Assessing the toxic effects of polylactic acid microplastics on aquatic biota, numerous investigations were conducted with a focus on the ecotoxicological assessment of microplastics made of polylactic acid, utilizing a variety of experimental model species. A vivid example of this are fish. Their consumption is recommended in the human diet. Therefore, it is crucial for the environment to evaluate microplastics and their subsequent effects on fish. Fish have the potential to accumulate and magnify pollutants which may have potential impacts on their consumers, which is one of the reasons why it has an impact on a human's health. Recent research has clearly identified that microplastics made of polylactic acid are developing environmental pollutants, just like microplastics from petroleum-based plastics. They are severely toxic to aquatic biota and might be a threat to human population as well through the food chain. Biopolymers and synthetic biodegradable polymers are a very important contribution to the environment, since they reduce a considerable amount of CO2 production, thus achieving a low carbon footprint. However, it is not a complete solution, since recent studies have discovered that it is still toxic for some marine biota. It has also been a concern that by making these bioplastics from biopolymers, we would be draining natural resources from our planet. Although the ideal would be not to consume any kind of plastics, it is a big change and a temporary alternative so we don't continue with the devastating destruction of our planet by using petroleum-based plastics. There is room for growth and expansion in many areas of the biodegradable plastic industry. Show it all estimates that plastic waste generation will grow by 15% per year for the next decade. However, it is ludicrous to expect a full replacement of conventional polymers by their biodegradable counterparts anytime soon. Expansion into particular niche markets seems to be the most viable option. Researchers worldwide are interested in the area of biopolymer development. The German government, Novamont, which is an Italian company, Queen Mary University in London, England, most of European nations, and much more nations are the front runners of biopolymer research. There are some areas of concern that researchers are aware of and are consequently focusing on. Multilayer films containing starch and or natural fibers tend to have adhesion problems. The search for an ideal processing technique to circumvent this problem continues. The biopolymer industry has a positive future, driven mainly by the environmental benefits of using renewable resource feedstock sources. The ultimate goal for those working in development is to find a material with optimum technical performance and full biodegradability.
Thank you all for your attention. We hope you liked the video and that you have understood a little about this broad topic of biopolymers. We provide the references in the following link. We thank you again and wish you a nice day.